Hello, this is Mr. Precella, and today we're continuing to work on the review sheet for Test 2. We're starting off with graphing a piecewise function. F of x equals 3 is the rule if the x value is greater than or equal to 1, or negative 4 minus x if our x value is less than 1. I've already written this problem, sort of color coding it. We have the 3 if x is less than or equal to 1 is the black rule. The negative 4 minus x if x is less than 1 is the red rule. Hopefully you can tell those colors. To graph this function, we start off by locating what I call the cut points on the x-axis. That's where we're going to be changing from the black rule to the green rule. So let me go ahead and draw a rectangular coordinate system for us. There. 1, 2, 1. So drawing the rectangular coordinate system, or maybe you have some graph paper, you locate the number 1 on the x-axis. So that would be right out there. I call that a cut point because it's at that number that you're switching from the black rule to the red rule. Now let's locate which one goes where. The f of x equals 3 is the rule you'll use for x values greater than or equal to 1. That would be to the right of 1. So I'm going to go ahead and label y equals 3. Notice I'm writing y instead of f of x. If you want to write f of x, okay. So this black rule is going to be to the right of 1. Notice how the symbol's pointing, okay? And the red rule, the negative 4 minus x, is for x values less than 1. That would certainly be to the left of 1. Notice how the symbol's pointing that way. So y equals negative 4 minus x. To graph these, I'm going to do it exactly the way I did in class. I'll draw my little xy table. Now, when you're graphing these, you've got to first always plug in the cut point. And remember, just like with solving inequalities using cut points, at a cut point there's got to be either an open or a closed circle, depending on the symbol. So I'm going to start off by plugging the number 1 in, and since it's a cut point, I'll have to put an open circle at this point. If I plug a 1 in here, negative 4 minus 1, negative 5. Then we need any other number. Well, it's not just a completely random number, it's any number to the left of 1. Don't use 2, 3, or 4 because you don't want this red graph to go past the number 1. So you could use a 0, and I think that's what I'm going to use. If you wanted to use negative 1, negative 2, negative 3, that's fine. When I plug a 0 in here, negative 4 minus 0 is just negative 4. Only at the cut points do you have the open and closed circles, since 0 is not one of the cut points. I'm just going to put a dot there. It's going to look like a closed circle. So write 1 down 5. 1, 2, 3, 4, 5. Open circle. And then over 0, down 4. Okay. Now I'll connect the open circle and the dot, and I'm going to keep drawing. When I connect it, I'm going to draw it up like this Why? Well, I don't want to draw it down, because if I drew it down this way, I'm going past that number 1 on the x-axis. This slanted line should be drawn to the left of the number 1 on the x-axis. Now, for y equals 3, I'll look up here, and 1 is a cut point. Since there's an equal sign on it, this is going to be a closed circle. So over 1 up 3, closed circle. Probably at this point we've already done enough to choose an answer A, B, C, D, but I want to graph it completely. So when you plug into y equals 3, you might think, wait, there's something wrong. There's no x here in this function. And that's right. This is called a constant function. It doesn't matter what your x value is. The y is always 3. So I'm going to go ahead and put a 3 down here. And I still need another point. So choose any number to the right of 1. Don't use 0, or else you're going to have the graph going to the left of 1. This black graph should only be going to the right of 1. So you could use a 2, a 3, a 4. I'm going to plug a 4 in. And notice, it doesn't matter what the x value is. Y is still 3. So when I connect, and this is just a dot, which looks like a closed circle. Okay. When I connect those, I keep drawing it out to the right. And you might recall we said that the graph of a constant function is a horizontal line. Okay? So looking at our answer choices, let's see. Oh, well, let's see. It should have a horizontal line at 3 with a closed circle going to the right. Well, the only one that looks like that is answer choice C. Okay? Now, sometimes students say, oh, well, hey, I can do this just by graphical analysis and looking at it. And yes, I'm sure some of you can. To spot the one that doesn't have the x in it, that's the constant function. So a constant function is just a horizontal or flat line. So a flat line to the right of 1 with a closed circle. Which one has a flat line to the right of the number 1 on the x-axis with a closed circle? Only this one. Okay. The other one is a slanted line, and it should have an open circle there. So answer is, I put in there C, yes. Now, number 11 says find the requested value. Well, this is just going to be a plug-in problem. Find f of -4. We said that with function notation, what's in the parentheses, you plug in for x. But wait a minute. Every function, for every x value, there can be only one y value. You're not going to plug this in, plug the -4 in for every one of these x's. Okay? You've got to choose which one are you supposed to plug it in. So for f of -4, your x value is -4. So is your x bigger than 9, between 4 and 9, or less than 4? It is less than 4. So you plug it in right here. 3 times -4 plus 1. That would be a -12 plus 1, so a -11. Answer B. I remember the semester when a student once said, well, how do we know which ones we're supposed to choose as the answer? Like if you plug -4 in right here, you'd get -16 and it's listed. But there aren't 3 different answers here, correct answers. There's only one correct answer. For every function, for a function, every x can have only one y. So you've got to choose which one of these are you plugging into. Okay? On that same number 10, just for illustration purposes, if we were using that same rule, if it had said find f of 50, if the number in the parentheses had been 50, you would be plugging into the top one. But boy, that's a bad teaching strategy for me to start changing numbers. So hopefully it's clear why I'm saying plug in here. You look at the x value, the number in the parentheses, and then see where it falls. Bigger than 9, between 4 and 9, less than -4. Oh, excuse me, less than 4. Now, problem number 12. A rock is propelled upward from the top of a building 230 feet tall at an initial velocity of 168 feet per second. Okay. So you can imagine throwing the rock or ball or whatever it is up in the air, and it's going to come down. Okay. Can y'all imagine throwing that rock? Oh, the lights went out. Oh, I hope the school paid their electricity bill this month. The function that describes the height of the rock in terms of time t. S of t equals -16t squared plus 168t plus 230. This is a quadratic function. Quadratic functions have to have a squared term. And this maximum here says determine the time at which the rock reaches its maximum height. That would be at the vertex. And so we have a formula for calculating this first coordinate of the vertex. Here, normally we write x equals, but this one it's a t, not an x. T for time, -b over 2a. B is 168, and a is -16. 2 times -16 is a -32. Now, let's punch that into our calculator. You see, I don't have a calculator with me. I'll just use my phone, which you can't use on a test. 168 divided by -2 is 5.25. So 5.25 seconds. This rock, that was a pretty good throw on top of that 230-foot building. Okay? It went for 5.125 seconds up in the air, and then it starts falling. So, let's see, which one is that? B. Now, keep moving on. Problem number 13 is another quadratic function.